let's start weather and meteorology. Okay, so weather and meteorology is a very important topic with respect to the aviation world. Okay, whenever we are flying any aircraft, as we are taking critical people and crucial people on board. So when we are flying aircraft, weather on meteorology topics is a paramount subject where every pilot should be aware of it, because
Right.
you never know when and how the weather would change, or how the weather will change for something like 20 kilometers, 40 kilometers, 100 kilometers in range. We do not know how the weather is at that particular location. Like if I'm flying from Mumbai to Surat, or Mumbai to Jaipur, or even Mumbai to Delhi, over the period of like 40 kilometers, every 40 kilometers your weather is different. Okay? It could be from with respect to the temperature, it could be respect to the wind speed, it could be respect to the visibility, all that things. Okay, so let's see. As we said, weather changes. Okay, every 20 to 40 kilometers. Atmosphere is a layer of gas that envelopes a planet. So we know the Earth, our Earth is having a layer of gas. Primarily the nitrogen, oxygen, all carbon dioxide, all these components which makes the atmosphere. It is covered completely from all the sides. But the Earth atmosphere varies vertically and horizontally. As I said, every 20 to 40 kilometers, you will see a difference in the atmosphere, difference in temperature, difference in humidity, difference in visibility. Lot many things like the pressure, temperature, humidity, density, all parameters get changed. So these are the critical parameters. When we talk about atmosphere, we need to see what is the pressure at that particular location, what is the temperature at
Right.
that location, what is the density at that location. So when we have a summer, the density will be lower, but when it is a winter, density is very high. Okay, similarly, when the I would say summer is at very peak, it increases the humidity also.
Right.
How it is. So it drastically can change. You see, when the humidity increases, there is a sudden rain is also started, or something like that happens. So all these are
Right.
interdependent upon each other, and each component affects the atmosphere. So all the parameters with respect to these four components, how it will impact the weather, we can't predict. Like we
Right.
try to do some simulation or something like that, but not necessarily every time we are. Sometimes meteorology department say that today it is going to rain based on their historical data and whatever they are seeing at current situation. But sometimes they go wrong also, because that is
Right.
something which is not controlled in a people's hand, or they cannot really. I mean, based on historical data and based on our understanding, we try to predict as well. Sometimes we are right, sometimes we are not right. Okay, so if you see the envelope of the layers of Earth's atmosphere, it starts with troposphere. Okay, it starts from the zero level or the ground level, till 12 to 18 kilometers. Okay, this is the biggest layer of the atmosphere, where the temperature is between 15 to 60 degrees. Okay, but if you see, this is the place where most of our balloons, our aeroplanes, all the things are actually moving. The hot air balloons I'm talking about. Okay, but as you climb beyond 11, 12 kilometers, okay, up to 50 kilometers is stratosphere. Okay, stratosphere is place where the weather balloons are basically flown to measure the temperatures or weather conditions and all that. As you see, as we are going up and up, our temperature drops. Okay, it goes into minus. Okay, so stratosphere again, you see the temperature is very low. As we go up mesosphere, again it goes further. These are the location where your satellites or rockets, they, or even the meteors, you will see in this particular region of the atmosphere. As you climb up, almost like 80 to 90 or 800 kilometers, I mean, say 100 to 800 kilometers, that is the thermosphere. Okay, that is where you will see these northern lights or auroras and all the things. But as you climb beyond 800 kilometers. That's the exosphere, where you will see our all the satellites and the spaceships and rockets all been going outside the more or less they are almost on the edge of the atmosphere, I would say. Okay. So that's how. But anyway, we are not, as of now, we are not going to fly drones in this segment. Our drone, as of now, it is limited only up to 400 feet of height. Okay, so not to worry. But these are sometimes important when we are flying a drone in a category of aeroplane. Okay, the predator drones or those things which flies at a very high altitude levels and all that thing. So that those come that time you have to think about this kind of atmospheric movements within the Earth's envelope. Okay, so troposphere, stratosphere, mesosphere, thermosphere, and exosphere. That
Right.
we have the segment on.
Are the temperatures correct? I mean, it's written 15 to minus 60 minus 56 degrees.
So if we talk about 12 to 18 kilometers, it is almost 18,000. So outside temperature, when you are flying in an aircraft, you are flying at 30,000 feet. Outside
Right.
temperature is almost minus 38.
Okay. Okay.
So you can't withstand if by mistake if you are outside the aeroplane, you cannot survive. That's why you must have
Right.
seen whenever those people who do those what is that gliding, air glider,
Right. Right.
standing,
Skydiving.
skydiving or anything. They are completely closed. They are wearing complete closed clothes and everything is packed. Okay, that's the
Right.
reason
Right.
you can't survive that temperature. I mean, your blood and everything will get what we frozen kind of
Right. Right. But in thermosphere, it's like minus 86 to 1200 degrees.
thing. See, again, the temperature varies from zone to zone also. Okay,
Right. Right.
it's not that here is 56 है तो यहाँ पे 56 से -2. So that is the variation in the temperature based on the like 11 kilometer it might be -2. You see, this is the range what they have shown, not
Right.
necessarily the
Right.
full it will be like. It depends upon how. Like this particular troposphere, if you are facing the sun side, maybe your temperature might be at a higher level. But if you are on the other side of the earth, like night side, in a troposphere, your temperature will drop. That's why they
Got
have
it.
given that range. So this is the range
Got it.
based on what it is actually. Whether it is with respect to
Right.
facing the sun side or facing the other side of the sun. So that's why that range is given in that troposphere. So not necessarily in a stratosphere in this particular range of 11 to 50 kilometers. Everywhere you will see 2.5. It will vary between these
Right. Right.
marks. That is what it is trying to say. Okay. So four components:
Yes.
pressure, temperature, density, and humidity are the critical part of the atmosphere, which actually we need to understand when we are flying a drone or an aircraft.
Right.
Okay, so what is weather? Weather is nothing but state of an atmosphere describing, for example, the degree to which it is hot or cold, wet or dry, calm or stormy, clear or cloudy. So we normally describe, weather in this form, whether it is hot. No, no, today is what today. Like today, I have gone to office in the afternoon, so it was very hot. All of a sudden, the temperature has now rose. Okay, mercury is going up now. So we see it is very hot nowadays. Couple of days back, it was very
Right.
cold, or even in the morning when you wake up, it was very cold. But all of a sudden, in the afternoon after 12 till 4 o'clock, it was very very hot. I was
Right.
almost sweating. I was
Yeah. Yeah.
outside. I was standing near the airport and watching helicopters landing. So I was literally sweating over there. I could not. I could not. I was just seeing the landings of the helicopters. I could not see
Right.
not more than two helicopters getting landed. I get inside completely. Well, yeah, somehow today it is not. I was feeling thirsty. So that's how. Sometimes the weather is hot. Sometimes it is cold. Sometimes we say wet. Sometimes it is dry. Sometimes it is very calm. एकदम peaceful लगता
Yeah.
है.
Yeah.
Very stormy kind of thing. Sometimes the visibility is very clear, or sometimes it is very cloudy. You can't see anything in the sky. Right now, if you see the uh, climate, It's very very clear. I mean, if you see in the night, far off, if you're staying in a high-rise building, or you are somewhere open in ground, you will see the night sky, especially the night sky is very very clear. You can see stars. You can
Yeah, yeah.
see
But that's mostly during your summers.
no, not summer. It's basically during winter. Winters you have a clear sky. Summers you will have cloudy. Depends
Oh,
again. Yeah.
yeah, yeah, yeah.
Mostly summer, since we are staying near to the sea, our summers will be cloudy.
Okay, okay.
Okay, so weather is the one factor in modern aviation over which man has no control. This is what I said, right? Whether we do not, though we historically we can understand, we can try to predict as much as possible, but still we do not have any control. We cannot control weather actually.
Right.
There are attempts been done like where there is no rainy, we are trying to do artificial rain, this, that. Where there is no sun, so people are trying to make some kind of a silvery uh, glass reflecting big mirrors kind of thing. They are trying to put it in the space so they can reflect the sunlight and make that particular location uh, bright and sunny kind of thing. Sometimes like artificial sun kind of thing. I mean, man is always trying to do something or other to control
Yeah,
things.
yeah.
Still we can't say that we have a control on it. Some extent we'll try to do it, but not necessarily every time we will be successful in that. Okay, so weather is one factor in modern aviation over which man has no control.
Right.
So meteorology is a branch of atmospheric science which includes atmospheric chemistry and atmospheric physics, which is the major focus on weather forecasting. To understand the meteorological hazard, their effects on aircraft, and how to minimize this risk first by those hazards. To identify the weather information that is required for each flight to interpret actual and forecast weather conditions from the documentation provided. So it's the job of a pilot whenever you are flying. Suppose I am flying from Mumbai to Chennai. So the weather in Mumbai would be different, weather in Bangalore would be different, weather in Chennai would be different. So on my flight path, if I'm going from that path, every 40 kilometers, I will see what is the reports of weather
Okay.
on my path, what is what, and that's how I will see what precautions I need to take. Is there any risk involved into it? Sometimes you might have a very good weather in Mumbai, but as you reach Chennai, you will see it is raining over there. So you should be ready for those kind of situations. You can't see that Are Mumbai mein to,
Right.
like normally people are Mumbai mein to, Mumbai is having very clear weather, and I didn't
Right.
expect that Chennai will be raining. You know, so
Right.
that's
Right.
what as a pilot, it's the job of a pilot to check what is the condition of the weather. You should read every day. Pilot should know if he's flying almost every day. His first job is to monitor the weather every day.
Right.
Okay, you need to see what is the current scenario over the Indian peninsula. Okay, how is the cloud movements happening? Where is the clouds? Where are clear skies? All that things.
Noted.
So you have to analyze and evaluate weather information before flight and in flight. Okay, sometimes when you are before flight means 1 hour, 2 hours you are analyzing, you might see that okay it is clear, but when you are actually flying on that path, you might encounter some change. So as we said, there is no control on the weather. Based on those four parameters, weather can change. So in
Right.
also you need to keep analyzing. You will be keep updated. Like most of the time, the respective ATCs. Like as you are flying, you are near Surat, for example. You are going from Mumbai to Jaipur or Mumbai to Delhi. As you are reaching Surat or reaching Ahmedabad, before that, as you connect to the ATC of Ahmedabad, they will brief you. They will tell you what is the current weather, what is the temperature going on, what is the visibility. All that information will pass to you so that you are prepared. So they will tell you, okay, currently this is the temperature, this is the visibility, this is the humidity, blah 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 things, whatever it is, clear sky, cloudy sky, whatever it is. We'll see that. It is called METAR.
Right.
Okay, so they will brief you about it. So accordingly you need to do sometimes correction. The ATC will give instruction also. You climb to so and so flight level, or you descend to so and so flight level, depending upon the weather, depending upon what cloud positions and all that things. So they will give you that inputs. A knowledge of meteorology will at least enable the aviator to anticipate some of the difficulties which weather may cause. So if you are having a good knowledge on meteorology, if you have planned the flight properly and you get regular inputs from the sources, you can anticipate and manage, or you can minimize the risk posed by those weather conditions.
Got it.
So that's what's the study of meteorology. It's a separate in topic. It's a separate. See, whatever we are learning, no, in this may be one particular course, but when you are actually becoming a aviator, okay, a pilot, these are individually one each topics. There are
Right.
books on meteorology. There are books on ATC procedures. There are books on the what do you call that, aircraft engines and all this. So every presentation what we are doing, there is in itself is a topic of 3 months. So much thing. Here we are just with respect to the drone. As of now, drone environment is a very small environment, and we are flying in a very limited condition, or we are flying in a very, I would say, it's not so big. As of now, it has not become so big. As we encounter, we start doing BVLRs. We're talking about flying beyond our visual line of sight, night flying. All those things once comes in, then these things will become also more important and more aspects. See, today we are doing a course of 5 days. Probably in future it could become a 3 month course also, something like that, because
Makes
there
sense.
so many things would be coming into, so many complexity would get it. As of now, drone flying is limited to our 400 feet and area of acre of land. Okay, 1 kilometer, 2 kilometer of area what we are talking about of flying a drone. But as things goes, more and more applications are coming into picture, and a lot of things would come into it, and then probably the course, maybe it could be a basic course, then advanced, and it could be intermediate, and then advanced kind of thing could be also possible in near future.
Right.
Okay, so as I was talking about METAR is nothing but meteorological aerodrome report. So every aerodrome or airport will have a METAR report. Okay, what we call as a METAR. So METAR gives us the required data such as wind direction, sorry, wind speed, etc. needed for safe flying. The drone operation, we need to cross check the METAR for safe and secure operation where we don't risk the drone. Okay. So if we are flying a drone into some particular segment, okay, we need to see what is the METAR for that particular location or that particular nearest aerodrome. Okay, nearest aerodrome, whatever it is. Like for example, we want to see the METAR of Nasik aerodrome, since we'll be flying close to Nasik.
Right.
But still, Nasik is almost. I mean, Nasik airport is almost
100 kilometers away.
190 kilometers away from our fly location. So it is not
Right.
really matter, because
Accurate.
yeah, it will not so much accurate for that particular location. So we need to, sometimes we need to judge our own condition of that particular location. But at least from a METAR, we will know what is the general weather at that particular location. Okay, so what is METAR is having? There are several mobile, even there are some mobiles apps are also available. Like these are some apps what have been listed. There are several mobile apps that provide real-time metadata. Some of them are mentioned. I mean, lot of pilots also in their mobile nowadays. You put these apps. Like I have been personally using this last one, the Windy. Okay, Windy gives you most accurate data about the weather. So Windy is there,
Right.
air data is there, drone buddy is there, drone cast is there, good to fly is there, or UVA forecast is there. So it gives a particular location wise the inputs about the weather conditions. Okay, so you can see here on the right side what was the time the sunrise, what is the sunset, okay, humidity, wind speed, what direction the wind is blowing. All that things will get, you will get it, and then it will also give you next 7 days how some forecast it will try. Not necessarily these forecasts are really 100% accurate. You can rely them
Right.
on 60 to 80%. on a particular day.
Does the digital sky platform also have this meter info?
No, no, no.
Okay.
As of now, it is not been integrated on that level. Digital sky platform. So for Meta, you have to go to respective airport websites.
Got it.
Okay, on their website they will put all the Meta reports and all that.
Right.
Okay. So international standard atmosphere. So international standard atmosphere is a static atmosphere model of how the pressure, temperature, density, and viscosity of Earth's atmosphere change over a wide range of altitudes and elevation. Okay, so what is the particular location? That's why I told every location. Like let's say you are sitting in Mumbai. Even in Mumbai city itself, the weather at Churchgate, weather at Santa Cruz, and weather at Borivali is different. Okay, that's why you must have seen we have a two weather monitoring locations in Mumbai also. One is at
Kolaba and
one is
Bandra.
Santa Cruz. Santa Cruz.
Okay. Okay.
So there are two locations here. Similarly, they have a small weather station in Palghar also. Like that, there are different locations where they. So the more weather stations you have, more accurate, more information you will have, more accurate predictions
Right.
you try to make it. So it has been established to provide a common reference for temperature and pressure and the consist of tables of values at various altitudes, plus some formulas by which those values are derived. So based on the location, like since Mumbai is at zero level, as you climb, you go to Lonavala, as you go to Pune, you are going on a high altitude location. So there again the temperature would be different, the pressure would be different,
Right.
so all that basically. Okay. But then looking at particular location or various altitude, you can calculate like okay, this is there. This is Lonavala is almost let's say 1,000 feet high. So I can know that okay, there would be a 2 degree difference. Like here it might be hotter. Like let's say it is 15 degrees. So at Lonavala, I can simply say that it could be 13 degrees. It will be cooler,
Right. Right.
something like that. So that is what how we derive the temperatures or pressures. Okay. So what is ICAO saying? ICAO published the standards of atmosphere is MSL temperature. Let's say take example of mean sea level temperature is what we are considering is 15 degree Celsius. Okay. MSL pressure, that mean sea level pressure is that is what 1013.25 hectopascal. Density will be, so these are all standards which they say at a
Right.
CDC are the standards. Now, if you see every 1,000 feet, okay, it is 1.98 or roughly you can say 2 degree difference. Okay, till 11 kilometers. That is at the range
Got it.
we actually fly our aircraft, 36,000 feet.
Right.
Okay, so every 1,000 feet, the 2 degree temperature will reduce. Okay, so every time 2 degree. Practically, we use lapse rate of 2 degree per 1,000 feet for calculation up to tropopause. Okay, so that's how we calculate, especially the temperature part. So as we climb every 1,000 feet, the temperature will reduce by 2 degrees. So if you see from
Got it.
50 degree, how much you will go down? Go down. Okay, it will go in minus, right?
Right.
Let's see now the pressure in aviation community in terms of yesterday we have seen QNE, QNH, and QFE are used to derive the standard pressure, local altimeter, and field elevation respectively. QFE is field elevation. QFE is the altimeter pressure setting at the takeoff location where it indicates the height. So when we are setting the QFE, when it is at a ground, that time your altimeter is reading what? Zero,
Zero.
right? And as you climb, whatever the height is there, it should show you that much height. Okay.
Right.
Whereas QNH is the nautical height. Okay. Nautical height is the altimeter pressure taking at the takeoff location reduced to MSL under ISI condition, which indicates the altitude. And then QNE is the altimeter pressure setting at the standard atmospheric pressure 1013.2 hectopascal, which indicates the flight level. So these are different levels. Okay. For a drone perspective, we'll always rely on the field elevation. Okay, because our drones are mostly flown on the terrain or a land
Right.
area. So our when drone is on a ground, it will always show you as a zero. As it climbs, it will either show in a feet whatever unit you have set, whether it is in a feet, you will show in a feet. If you have set it into meters, it will show in a meters. Ideally, we always read a height in a meters because that is what universally people follow. Okay, because feet is not a very standard
Right.
unit to measure the height because it doesn't give you the clarity. Feet is actually an old unit used by British. Okay, especially the inches, feet,
Yep.
pound. These are all British units, whereas the international standards are meters, centimeters, millimeters. Those the way they are being divided. Okay. So from a drone perspective, always see what is QFE. Okay, the field elevation. Okay, so this is QFE. This part what you need to keep in your mind. So if you see the mean sea level, okay, that will be where we will be measuring the altitude. From the QNE perspective, you will always measure the flight level, but with respect to the terrain or the ground or with respect to the airport, nearest airport, whatever it is, if you see the zero level for it, that will be your base zero, and from with that respect to that, you will always measure the height, either in meters or in feet. Okay, but standard practice is to measure in meters always.
Right.
Okay, again another way to explain the same thing. Okay, so if you see here, uh, for example, with respect to this, because terrain will be always not same, right? So plus minus. Like for example, earlier, if you see our earlier, our flying ground was also having three depths. Like our flying ground was actually like this. Okay, so it has a like every depth. This was almost like 1 foot, 1.5 foot difference was there in the ground. There was
Okay.
1 foot, 1.5 foot difference was there. So when the DGCA people have come for a survey, they objected. Okay, so they said we can't have a field or a ground like this. You need to have a flat ground. So we removed the what we call the material from this side, and we filled all these things here. So and we made a
Right.
flat ground like that. So when you go to the field, you will see. I will show you the difference from the road. Almost 3 to 4 feet we are down. Okay, that's how
Okay.
almost 20 days, day and night, the JCB and tractors were deployed over there.
Right.
Because the DJCA told us that within a week you need to get this sorted out, or else you will not get the approvals or authorization. Okay, so we got that around the clock, almost every day, night, things were worked, and then we got it clarified, and then we shared the images, pictures, and photos to them, and then only we got it. Because in the drone it was showing the difference. So when I was flying a drone at this location, it was showing different. As since my drone was having altitude setting set, so what happens? My drone never flies in a straight direction like this. So it will always follow the terrain. So when it comes here, it was coming down. When it is coming here, it was coming down. It was not able to maintain the same altitude at every terrain. Okay, so it was
Okay.
trying
Okay.
to maintain the altitude with respect to the ground. So for the for this it was zero ground, but when it was coming, see because it is on the IMU is constantly measuring the height. It is sending a signal. There is a radars. There are radars put on the drones, which sends the ultrasonic waves and it measures the value. So every time it will
Is
get a
it like a sonar?
yeah, it's like a sonar. So it will always measure and it will give inputs to IMU, and so drone will automatically controls or correct itself, and so it goes down. That was it. That's why it is advisable that we should not fly a drone on the watery areas, okay, because it will not get the proper readings when it is on water. Okay.
Got
Then
it.
you have to configure the drone accordingly for that particular activities. Okay.
Yep. Yep.
Now, after temperature and pressure, what is the speed? So, to measure the speed or measurement of the wind speed, there is a device called anemometer. Okay, it is a device that is used to find the wind speed. Earlier, we used to use wind socks. Okay, we have a wind sock or
Yeah.
DPC
Yeah.
deployed, but uh, sometimes windsock is very, I would say, at a very broad level you can measure the thing. But if you want to measure a more accurate, then normally you will use analog or a digital anemometer for reading this. Nowadays, mostly everybody uses digital anemometer only to it. It's hardly, I think, something around 300 or 400 rupees it costs. Okay, so digital handheld anemometers are available in market, which a drone pilot must always carry with them to cross-check wind speed at the time of operation. If the wind speed should not be more than the permitted limit by the manufacturer at the time of the drone operation. So again, based on different drones, like your DJI drones will not withstand something around 15 nautical miles of wind or something like it. It will start drifting. Okay? It will not be stable. Whereas the bigger drone, which has the capacity to hold even at a higher wind speed, they will able. So you have to follow what is being specified by the drone manufacturers. So our drones are more than enough, and I mean, since they are at an industry grade or agriculture drones, they are being designed, and because of their weight capacity also, they are not so easily affected by wind, even at let's say 15 nautical miles kind of. Okay?
Because of the weight, right?
Because of the weight.
Okay.
Weight as well as the controls what it has, the GPS modules, and even the modules and the way it is configured, to correct itself, even if there is a slight drift and all that thing. See, if you do not put those corrections and all the thing, it will never be stable. It will keep on drifting. So it has to counteract. So it will manage the speed of the propeller so that even there is a drift, it will control it and try to counteract that thing. But if you see the other
Right.
drones, though DJI drone, like you take example of Phantom, though it has a very good controllers and everything, but because it's so lightweight, it cannot push the wind. 15 nautical miles wind, it cannot push, right? It cannot pressurize. Some extent
Yes,
it
sir.
will try to do it, but since it is a very lightweight compared to 20, see, it is just 2 kg. 2 kg weight compared to 2 kg and 24 kg is almost 10 times difference is there. So pushing
Right.
something 2 kg device and pushing 24 kg device at a wind of a 15 nautical miles will definitely show the difference. Okay, so
Yeah, yeah.
windsock. So if you see the windsock is something like this red and white color. It's just a cloth or resin kind of strips. White and orange strips are there sometimes, or white or red strips are there. Okay, so if you see based on their position, like if you see this first, okay, there are five sections: one, two, three, four, and five. Five sections. If only the first section is horizontal, and remaining four sections are falling down, or slanted, then it is 3 nautical miles. 3 knots. What normally we say 3 knots. Okay. If first two sections are horizontal, then we say 6 knots. Then 3 knots, three sections, it will be 9 knots. Four sections, it will be 12 knots, and then all five, it will be 15. So every section is
Right.
a multiple of three. So 3, 6, 9, 12, and 15. So it's very easy to
Right.
understand. So if this is the position wind is flowing, your windsock is looking like this. That means you know that you can feel it's a very high speed wind is flowing at it. It is almost 15 knots. That means 28 kilometers or 17 miles per hour. The wind is flying. Okay, wind is flowing, kind of thing. What we
Right.
say. Okay. So ideally, we fly up to 9, sometimes even up to 12. But if it is 15 knots, we try to avoid. Okay, because we don't want to take risk and all that thing. Because while we training, we'll try to see, in a calm position, we'll try to fly the drone, because that is the drone where we able to control things as our requirement, and it will not pressure or it will not consume your battery so much. Okay, so you will
Got
get
it.
maximum flat time when it is somewhere around 3, 6, or up to 9 knots, I would say. Okay.
So basically, at higher pressure, the IMU of the drone might have to do more work.
Yes, not only IMU, IMU will capture. See, IMU is every time capturing the inputs. Even
Right.
there is no wind, that is also it has to measure, right? The device
Yeah.
has to
Yeah.
measure all the inputs and give the inputs. But when
Right. Right.
high pressure, the IMU will give it. So that time, the flight
The
controller is
motors
having a
will
lot of
be
computation. Flight controller has to do a lot of computation
right.
and has to give inputs to propellers. To maintain
Right.
this, it has to fetch the signal from GPS. It has to see how much it has been drifted. It has to bring back to the original position, or it has to counteract with that speed to maintain that GPS or those
Right.
latitude or longitude points. Okay, so your flight controller is at very much on computational side.
Got it.
Okay. So we talk about the wind. So there are different types of winds. So gust is a sudden increase in wind speed, often with change in direction, lasting less than 1 minute, and it is a local effect. I mean, it is just. I mean, it is not that necessary. It will be everywhere. All of a sudden, if you're seeing, if you're standing on a ground, open ground, all of a sudden the wind will. I mean, it is just a point in time at that particular location. Not necessary. Entire Bandra will face the gust. It is just a sudden change,
Right.
and it will not be lasting more time. Hardly 1 minute. Okay, a lull is a period without waves or wind. Okay, it means there is a gap. Gust, there is a gust, and all of a sudden everything becomes like what is it? Nothing would have happened. Silence, trend of silence. Okay, it's a period without waves or wind. Nothing is happening. All of a sudden, the breeze will come, it will blow, and all of it will become very calm. So that is lull.
Right. Right.
Gust and lull are always after the gust. You will always see the lull. Okay, it's a period without waves or wind. Whereas gust is a sudden increase in wind speed, often with change in direction. See, this you can feel when you are actually flying the kite or something like. All of a sudden, your flight the kite direction changes. Okay,
Right. Or else it will start to fall.
yeah. Yeah. Whereas squall is a sudden increase in wind speed, often with change in direction, but lasting for 1 minute or more and can cover a wide area. Okay, earlier it was local, whereas and it was less than 1 minute. Here it could be more
Right.
than almost 1 minute or more and can cover a wide area. Skull is really important to be predicted. Carelessness on the part of the skull can result in crashes of drone and hence loss. So we should, if we see there is a weather is getting changed and everything, we should immediately stop our operations. Okay?
Right.
So that is what it is trying to say. If you feel that okay, there is, you can feel, you can feel the wind speed, you can see the temperature drop or increase in the temperature, or you can feel that if you feel something is going to change, changing the weather is changed from what was there initially, or 1 hour or half an hour before or 15 minutes before, you should immediately stop your operations. You should try to take as much as precaution, maybe like landing your drone where it is as it is. Okay, don't take chances at this point in time where it will cost you the drone. Okay.
Got it.
Gale is nothing but a gale exists when wind speed exists 33 knots. Okay, whereas hurricanes exist when the speed exists 63 knots. So these are very high speeds, winds. So sudden at this 33 knots or 63 knots, it is completely no for drone flying. Now, these are some relation with respect to normally when we talk about the wind speed and all thing, we normally talk about in knots, 1 knot, 3 knots, 6 knots. You have seen it, but somebody like
Right. Right.
asked you in a kilometer. So what is the conversion? So one knot is equal to 1.852 kilometers per hour, or 1 kilometer again. If somebody want to know it in miles per hour, that is how the conversion happens. Okay, so you can use this formula to find out if somebody talks about 3 knots. So it is 3 into 1.8. Okay, so that's how you will know what is the kilometers per hour
Right.
the wind speed is. If somebody want to know about. But in a general terminology, we always talk about wind speed you must have seen in the movies also or any conversation happening.
Yeah, yeah, yeah.
They will always talk about knots, 3 knots of the wind speed is flying.
Right.
Okay. So now the cloud is nothing but is a mass of minute water droplet or a tiny crystal of ice formed by the condensation of water vapor in a free air at a considerable elevation. Okay, as clouds are formed at some height over the surface of the earth, they take various shapes. So it's basically condensation of a water vapor in a free air, considerable elevation. So you will see clouds at a different heights. Okay, so according to their height, the expanse, density, and the transparency of clouds are grouped under 4 types. So based on their height, their expanse, their density, and the transparency of the cloud, they are grouped into 4 different types. So there is a cirrus clouds, there are cumulus clouds, there are stratus clouds, and there are nimbus clouds. So now let's see what are these different types of clouds. So cirrus clouds are formed at a height of altitude of almost 8,000 to 12,000 meters. They are thin and having a feathery appearance. They are always white in color. So you might have seen this kind of clouds
Right.
at night. If they are very thick, formed at a height of almost 4,000 to 7,000. Okay, but they exist in a patch. Now here, see, looking at the cloud, the feathery, feathery appearance and white in color. Whereas here you can see they exist in a patches, highly dense kind of thing. Okay, but they are still scattered, so they are cumulus. The simplest way to look at or understand them is, see here they are saying feathery appearance, whereas here they are appearing like a cotton wool.
Cotton.
So looking at the shape or the way they are visible to us, we can understand this is cirrus clouds, whereas these are cumulus clouds. Okay. Whereas
Got it.
next, again, these are layered cloud covering large portion of sky. Here you will see these are all patches, very scattered kind of thing. But if you see here, they are covering large portion of the sky. These clouds are generally formed either due to loss of heat or mixing of air with different temperatures. Okay, so this you normally this type of clouds you will see it early morning nowadays. If you wake up tomorrow early morning, you will see sometimes this type of. These are only for a shorter period, but again, stratus clouds at this point in time.
Right.
Okay.
Okay, sir.
Whereas the nimbus cloud you will see mostly during the rainy season. Nimbus clouds are black and grey. They form at a middle level or very near to the surface of Earth. They are extremely dense and thick, so they don't have any shape. So they are complete cloud cover. Nimbus clouds are very like we normally say what weather is this? Not a good weather. Okay, so it is completely cloudy. You can't your visibility gets reduced, and they are so dense and thick. So people avoid actually doing work. Even no, even you are not related to anything to aviation or anything. You do not feel okay because suddenly the feeling of the good weather goes down and you feel that these are not good weather or they are black gray, the light also dip down, the temperature also bit dips down sometimes, and in a rainy time you will see it start raining and all that thing because of this nimbus clouds, and they are very close to the or very near to the earth's surface. Okay, so that's why we in the rainy season we'll see rain, it's raining continuously and all that.
Right.
Okay. So weather impact on US operation, cloud based 9,900 feet distance to cloud, 2,000 feet. VLOS impact, the visual line of sight. Okay, visibility less than 3 miles. VLOS impact, fog, cloud precipitation, airframe load, short circuiting of electronics, VLOS impact. So a lot of time because of most of the equipments are, I mean, the motors are open motors. Sometimes even you are like yesterday we have seen that drone, it was not having a cover or thing. So those are not drones which are supposed to be flown in this kind of conditions like foggy, cloudy, or precipitation or icing. Critical performance and safety issues also happen during the icing. So if you are flying drones like in area like European countries or in Kashmir, all that locations, icing lot of happens. Lot of time icing is there on the propellers, on the motors, on the frames. So sometimes because of the icing, also the weight of the drone changes, and it also impacts the aerodynamics of the drone also.
Right.
is as of now not so impactful for a drone if you're flying a quadcopter. This is only with respect to the aeroplane. Okay, if you are flying a aeroplane category drone, then only this will come into the picture because that will be a drop in the communication due to radio frequency interference. Whereas wind and wind shear, loss of control, inability to return home or mission failure. Okay, for a small quadcopter, these are not much importance. If you are flying within a short distance of your mission or
Right.
if you are doing a bigger missions in future, okay, under previous condition, this will also play a big role because we never know. Like I'm sitting here and I'm flying a drone almost 5 kilometer far. I do not know what could be the wind speed at that location. I will rely on what the drone is sending signal, and I am seeing on either on my remote or on my ground control ground support.
Right.
Okay, so based on that only I will able to see what is what, and accordingly we need to take a decision. Sometimes because of heavy wind and all things, sometimes if even we try to initiate return to home feature or something like that, it may not function like that. Okay. Again, then moderate or greater turbulence, so your reduced mission duration because of turbulence and all this sort of time. We have to either call out our missions or we have to you know land our drone as considering the safety of the particular drone also.
Right.
Okay, so these are some of the impacts of the UAS operations due to weather. Okay, so if you see here, I'm here, okay, flying the drone. I'm seeing it. See how as I move away, the drone moves away from me. See how drone is getting disappeared.
Right.
So zero point 0.5 miles, that is 500 meters. I can see. Okay, I'm just converting. It's not zero point 0.5 miles is 500 meters, but I'm just from over. So imagine this is in kilometers, zero point 0.5 kilometers.
Right.
Okay, so 500 meters. At 1 kilometer, it will be less visible. As it goes further, 1.5 kilometer, it will be less visible. Almost at 2 kilometers,
Right.
I will start. I mean, drone will start getting disappeared from my view. Okay, it is very hard for me to visualize. You see, at 2.5 miles, it will be more or less. It will not be visible. Definitely at 3 miles, it will be complete loss of visibility. I can't see the drone from this position. Okay, so that's why I say normally we say in VLOS, though it is said that we can fly drone up to 3 kilometers, but our eyes are not so. I mean, we need again. It is subjective, subjective to the person, subjective to the place, and subjective to the seeing conditions. Okay, so all these three factors are subjective: person, location, and the weather. Okay, so somebody might able to see a drone up to 2 miles. Somebody may not able to see a drone even at 1 mile, kind of thing. Okay, that way. Dense fog. So as we move away and away, so it will be dense fog, foggy kind of thing. So cloud and fog are both formed when water vapors condenses or freezes to form a tiny droplets or crystals in air. Cloud can form at many different altitudes, while fog only forms near the ground. So you will see fog mostly happening in the valleys, okay, or wherever there is a water body there, nearby. If you have water body, you will see more fog forming on the ground and all that things. Okay, whereas cloud is basically in the air. Okay, it's high up, so
Right.
fog is always closer to the ground. So sometimes that's what I told you. When I have gone to uh, Haryana for my master training in certain states,
Yeah. Yeah.
2 days I could not really fly the drone because of the complete foggy. I'll show you the picture or I'll share that picture how it was. I mean, I opened the window of my guest house. I can hardly see the farm from that location. This is how it was looking, foggy kind of thing. Hardly, next more than 100 meters, I could not see the further. Like in this condition, I cannot really fly a drone because I at least I need to be at least 10-20 meters I should be away from the drone when I'm flying or taking off.
Right.
Okay, and then it will go further, so it will go further like almost 50 meters or 100 meters. If my visibility is not there even at 100 meters, I should not conduct the operations. That is what it is followed. The fog is a
Right.
defined cloud with its base at or very near to the ground. Fogs are caused by the cooling. As the air cools, it becomes denser and drains into low areas such as river valleys, where thick fogs accumulation may occur. That's why you see most of the time the fog is in the winter part, winter season. Most of the time you see in winter you will see the fogs, or sometimes in the early morning part or in the evening part. Okay. Fogs are caused by the evaporation. When the cool air moves over the warm water, enough moisture may evaporate from the water surface to produce the saturation. Okay. So, in simple rule is that whenever you see your visibility is not uh, beyond 100 meters, you should not fly your drone. As simple as that. That is
Right.
what we are following in the drone operations. Like when
But how do you know, I mean, that it's 100 meters or what it is?
100 meter is very simple, na? Like for example, um, when I keep my drone, let's say my field, okay, in my field is 60 meters by 60 meters. Okay, 60 by 60 is my square of my meter, so I can know how much far it
Right.
is. Okay, so if I'm standing on one side of my boundary, the other side of boundary should be visible to me. So 60 meters,
Right.
another 60 meters will be 120 meters, so that is 100 meters for me, roughly.
Right. Right.
So that is how I know whether I can fly my drone in my field or not.
Right. Got it.
Icing basically has a lot of time, caused a lot of air crash uh, in the civil aviation.
Right. Right.
Lot of icing.
Hence they do icing.
Yeah, hence they do those icing things. Or there are sensors are been put on the wings, and they it is called de-icing. Okay, that is called de-icing
Yeah.
procedure. Okay, so uh, it's a job of a pilot before takeoff. From his cockpit, he should able to see the condition of the wings. So your
Right.
leading edge is a bigger edge, broader. That is where you will have more icing, and
Right.
it impacts the performance of a wing, aerodynamics of the wing. Okay, it makes the
Right.
wing heavier also. Okay, so that is a very serious issue. Okay, so freezing rain is a common ahead of warm fronts in the winter. Serious icing occurs when the aircraft is flying near the top of the cold air mass beneath the deep layer of the warm air. The raindrops are much larger than the cloud droplets and therefore give a very high rate of catch. In a freezing temperature, they forms a clear ice. Okay, so this is very very dangerous. So even not only because de-icing, there are hot air tankers are also there, which puts those hot air on those wings before the takeoff, so that entire ice
Right. Right.
being evaporated. You might have seen sometimes, that you must have seen whenever there is a new aircraft comes, how they welcome it. There are two tankers have been kept, and they,
They salute.
yeah, they said that. But those actually tankers have been used during those de-icing things. They have been kept for those purposes, either for de-icing, hot air de-icing water is there, or they are used for cold water or normal water during any fire or anything. They have been
Right.
used those tankers. Okay. So how does the structural icing affects the flight? Effect of icings are cumulative, so it will basically decrease the lift, weight will increase, it will decrease the thrust, and drag will increase, and a lot of time you have a stalling speed increases. So normally you will see your aircraft is not performing as you intend to perform it in a normal conditions. So you will know that because of that. So in the, sometimes uh, when you are flying at a very high altitude and icing is happen, so some aeroplanes like especially Airbus or Boeing, aeroplanes, they are mandatorily fitted with the de-icing devices on it. So they will always activate those de-icing things on it. Because even there are sensors on the wings, pitot tips, what we call. Those also nozzles get icing, and you will not get the accurate readings of your wind speeds or pressure, temperature, or even your density. All those sensors will also get affected because of icing. That is the reason why you will always have a de-icing thing on the wings, especially the horizontal wings.
Right, right.
So it affects your lift. Your weight naturally will get increased because of the additional weight of the ice. Thrust will decrease. Your ice will build up, which will cause the drag. Okay, because you are having more surface, more friction will cause, and that will automatically reduce your thrust and
Trust.
speed, and which will also cause stalling speed increase. When you are being, as you are trying to take off, I mean, you are trying to pitch up, it will not pitch up. It will go down. Try to go down.
Right.
Okay, stall will happen startup. So you have to, when this type of things are happening, you should not do too many things at this point in time. You should try to maintain the altitude and maintain the direction. Okay, though if you are going slow, I think you try to see how much, or you try to go lower. So as you go lower, your temperature will increase, because sometimes if it is not because of de-icing feature and other is not working, the pilot will take a decision that let's descend. Will descend. The more you come closer to the ground, the temperature, because as we said, every 1,000 feet, the 2-degree difference is there in the temperature. So as you climb down, I mean, as you descend down, your temperature will increase. So let's say you are at,
Right.
let's say, 12 degree. As you climb down 1,000 feet, you will be like 14. Again 1,000 feet, you will be at 16. As you climb down, again it will be 18. As you climb down, it will be 20. So automatically you will take advantage of the altitude, and that's how you maintain it. And as you are away from that particular location, then again you can climb. So that's how you normally do it. Because if you see this kind of planes, I'm talking about Boeing and Airbus, they are having, but these type of planes like Cessna and all the things, they do not have de-icing and kind of things on their planes. Okay, the smaller charter planes, especially the
Yeah,
charter
yeah,
planes, will not have those features or those things equipped for those kind of things. Okay, so that is how they fly their charter planes, maybe lower compared to where it is getting icing and all. Okay, lightning. Lightning causes thunder, a sound from a shock wave which develops as the gases in vicinity of discharge. In vicinity of the discharge, experience a sudden increase in pressure. Lightning occurs commonly during the thunderstorm as well as other types of energetic weather systems, but volcanic lightning can also occur during volcanic eruptions, like in Indonesia where you are having a lot of volcanoes happening and all. Sometimes
right, right,
the atmosphere becomes sulfuric, and you can see the lightning happening, and it can impact the aircraft. Though now aircraft are also fitted with anti-lightning features and all that things, but it is always, as a pilot, you will always try to avoid this kind of scenario. So anything which is impacting the pressure, impacting the performance of my aircraft or a drone, I will try to see as much as avoidance. My first step will be to how to avoid this scenarios. So you have to. That's why
right.
we study weather and meteorology, is because so that we can, rather getting into situation. It is always, prevention is better than cure. How we say. Similarly, prevention is always better than getting into those kind of risk scenarios.
Also, but what does actually anti-lightning devices even do? Like if you look at planes, they are so huge. Even a plane इतने बड़े होने के बावजूद if a lightning strikes it once, it's gone. तो drone तो फिर भी plane से बहुत ज़्यादा small होता है. तो anti-lightning devices कर भी क्या सकते हैं?
See, in a plane, it just discharges. Okay, it so your electronics are being actually fitted in a such a way, those discharge or those lightning impact doesn't impacts your electronics or avionics. In a drone
Okay.
also, you will try to see like where are your chances of getting it. So you will always have a canopy covered with it. If you're keeping your avionics open, you are inviting that lightning will definitely strike it and it will get
Right.
impacted.
Hmm.
So you will put a canopy in such a way that, or you'll try to direct. Like for example, how do you prevent a building from a lightning? So you will normally see on a high-rise skyscraper a metal rod is been put. Okay, so
Hmm.
it will the lightning will always
Absorb it. हाँ वो
always
stick.
impact the highest point of that particular structure. Okay,
Hmm. Got it. Got it. Got it.
what is your highest point compared to the skyscraper? That rod. Okay, especially you see the heritage buildings, they will be always fitted with the lightning discharge rods. Okay, like
Right.
Okay. Okay. Got it. Yes. Correct.
and or anything like that. Even temples have been fitted with like that already. In fact, temples are been designed in such a way that they can absorb the lightning and all the things. That metal
Hmm.
part on top, or the rods for fitting the flags. All those are like that. But then there is a wire been put up, and which actually gets grounded to the earth. That's how you discharge your lightning and all. In a plane, basically, what is that you need to make sure that your devices, your avionics are being covered so that the lightning is not affected because there is nothing to ground over there because it's in the air, right? It's not connected to the ground. Your lightning cannot be grounded when the aeroplane or drone is in the air. Okay, so how do you protect your devices? So you need to make sure that you are covering your avionics uh, in a canopy or kind of things so that it doesn't directly impact because of the lightning.
So basically, it needs some direct contact with a metal, then only it will strike.
Correct. Okay, what is wind shear? Wind shear is sometimes referred to as a wind gradient, is a difference in a wind speed or in direction. I mean, change in the wind speed, okay, different direction over the relative short distance in the atmosphere. Atmospheric wind shear is normally described as either vertical or horizontal wind shear. So it depends upon what sometimes upward wind, downward wind, or horizontally wind difference you will see. So vertical wind shear is change in the wind speed or direction with change in altitude. Okay, vertical up and down. Whereas horizontal wind shear is change in the wind speed with the change in a lateral position for a given altitude. Okay, that's how we define different types of wind shear. This is change in the speed. All of a sudden, whatever that gust what we talked about, right? So that's the change in the wind
Right.
speed. All of a sudden, that is what we call as wind shear. But how the wind shear, whether it is impacting in a vertical scenario or in a horizontal scenario. Okay, if it is in vertical scenario, it is called vertical wind shear. When it is changing in a horizontal scenario, then it is horizontal wind shear. Okay, you can see it. All of a sudden, you can see the change. Okay, vertical wind shear. From this position again, suddenly the wind is difference in the speeds. Okay, so you can see the change. You can see. I mean, this is just pictorial representation in a cloud way,
Right.
so that you can see the cloud is rising up. Okay, whereas in horizontal wind shear, you can see cloud moving laterally. Okay, lateral movement of the cloud and all the things. So that is horizontal wind shear. If the clouds are rising, you can see that it is called vertical wind shear. Okay,
Yep.
turbulence. Now we lot of time when we are in flight, we might have encountered this kind of scenarios, right? What is the
Yes. Yes.
is the thing which normally every pilot will not like. Any pilot will not like it. Okay, so it's a sudden violent shift in the airflow causes wind, storm, jet streams, object near the plane, particularly mountain ranges and all. So a lot of time we will see there is a change in the altitude or change in thing. We'll see turbulence. Actually, I have seen most of the time. I keep on talking about example. Whenever I am flying Mumbai to Delhi, I have seen lot of time. There is a turbulence you will see when you are near to Jaipur or those kind of locations. Okay, because the temperature at that location is very high. Okay, and all of a
Right.
sudden, because the terrain what is there at that point, if you see Rajasthan, it's a very flat. what we call sandy kind of thing, and temperature is very high and all that. So there is a very
Right.
possibility of change. So I have most of the time whenever I am flying from Mumbai to Delhi, especially when going from Mumbai to Delhi, either early morning or in the evening, I've seen we have encountered most of the time turbulence. Okay, so lot of time, you will have. I mean, those are very common type of turbulence you will follow. Pilots are now so much trained, and actually when you're flying these commercial aeroplanes, the actually plane is not flown by the pilot. They are
It's
not
mostly
actually.
autopilot by
It
the
is not.
computer.
In today's aviation world, pilot is not supposed to do anything. Even takeoff is taken
He
care
just
by the
monitors.
pilot. He just have to monitor. He's not supposed to take even decisions also. Like, he cannot
Right.
change on his own things. Okay, he will be instructed. He will be told, and he has to follow the complete textbook flying, or he
Right.
has to follow the standard operating procedures what has been defined. Okay, in case of something going wrong, that scenario also there is a procedures been defined. If
Right. Right.
something which is not defined and something beyond what is not been there, then only you have to take decisions. But that also you need to communicate, talk. I mean, that's where actually your communication. That's why we have that topic etc. Communication and all this. So you
Right.
communicate how and what is happening. They will also try to help you out what needs to be done. They will say, okay, you climb, you go down, whatever it is, that kind of thing. So that's how
Right.
commercial flying happens. So actually, though you feel that when you're flying as a pilot of a commercial aeroplane, it's a very prestigious position, as a pilot captain. But actually, when you're sitting inside a cockpit, you're doing nothing. You're just keep on monitoring.
Yeah.
Smaller distance like Mumbai to Jaipur, Mumbai to uh, Delhi or Chennai, where it took 1 hour or 2 hours. It's okay. But think about people flying from UK to Australia, UK to Sydney, or from Singapore to New York, kind of, which talks about
Right.
18 hours, 18 hours in a air. I
Right.
mean, it's very, very, though you are not doing anything, it's very stressful.
Yeah.
And that's why you will see most of the time
Multiple pilots.
multiple pilots like there. Dreamliner, I think you have from four pilots are there. So two are
Right.
sleeping and two are actually doing work.
Right.
They have a sleeping sections also there in those aeroplanes. Think of
Right.
18 hours. I mean, if I have to drive a car for 4 6 hours, also it is so painful.
Very tiring.
18 hours means it's like I mean, you can't do. I mean, you are in a very confined space. In
Right.
car maybe कैसे at least you can stop na somewhere near the road.
Exactly.
You can stop, you can stretch, do all the things. But
Yeah. Yeah.
you must have seen there was one funny thing like video or something was there on internet.
Mhm.
I was seeing. I mean, there was one jet fighter pilot who was flying, and there was one guy who was flying the
Yeah.
commercial
Yeah. Right. Right. He was in his Boeing.
going. It's very funny. I mean,
Yeah, the fighter pilot makes a
pilots,
lot of stunts and all, and
yeah,
he says that, see, I could do so many things in this, and then that other Boeing guy says, wait, let me show you something, and then he does nothing, and when he comes back on, the fighter guy asks, ki, Arey, what did you do? Then that's when he says, I went to the washroom, I had a good
coffee.
coffee, hot coffee, and I took a short nap and I came back.
Can you do that thing for me?
Exactly. Yeah, yeah.
That's it. I mean, it's very funny. I mean, that's how the comes in.
Exactly. Yeah.
Every aircraft you fly has its pros and cons, or
Right, right.
enjoyment of it.
Yeah, the way they basically say that Boeing is more of an aircraft wherein the pilot has to do a lot of things, but Airbus is more of an aircraft wherein the person has to just monitor things.
Both are like same, no difference.
बट अब
Yeah.
तक आई यूज्ड
Right.
टू थिंक कि पायलट्स 24/7 मतलब जितने भी टाइम का ड्यूरेशन रहता है फ्लाइट का पूरे टाइम फ्लाई करते हैं.
Huh?
वो
Sorry.
Autopilot पे डाल के they sit and they just monitor.
Monitor. They have to sit and monitor, and
Yeah, yeah,
they have to just read out if there is any change or
हाँ,
this.
अगर minor time के लिए तो they'll have to do it. If there's a turbulence और कुछ तो they'll take over. But
They
if the
take over.
sky is clear
no,
और
they don't.
छोटा way है.
Even in turbulence, also the autopilot will take care of everything.
Oh,
They will only communicate. They will say that, okay, ladies and gentlemen, we are just encountering turbulence and we are managing.
Right.
They will say, but they are
Please
not
keep
doing
your
anything.
seat belt fastened.
Yeah, please put your seatbelts.
oh,
All that things they will say, but they will not do anything. It is all everything
Exactly.
on autopilot. Autopilot will. It is advisable that you should not change in turbulence also from autopilot. You have to be in autopilot only. You can't put it in manual and you can't do. See, autopilot is much better to manage those scenarios than the person actually. If it
Right,
oh,
right.
okay.
beyond autopilot or autopilot is not functioning the way it should function, then only the pilot is supposed to be taking the over it. That's the judgment of the pilot where it is to be. But nowadays it is not 99%. I would say not also 99. 99.5 times 9. You are not supposed to disengage the autopilot. If you
Okay.
something happen, you are questionable that why did you disengage autopilot.
Right, right. In fact, even your landings are autopilot.
Yeah, autopilot. That's why instrumental landing, what we call ILS.
Yeah, yeah.
Okay. So turbulence, light turbulence momentarily cause the slight change in altitude or attitude, slightly bumpiness. Occupant of the airplane may feel a straight strain against their seat belts. Then you will see bumping, Tick, 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 tick. You will see. Sometimes some people feel very frightening, because there is nothing to support. People start getting worried about that one day. So, most of the
Right.
air hostess will try to calm you, try to give you some water or something like that. The moderate turbulence is the similar to the light turbulence, but somewhere more intense. There is, however, no loss of control of the airplane. Okay, so most of the time the turbulence are being managed by the autopilot and all this. But in a drone scenario, like if you are flying an aeroplane kind of drone, then probably you may have to abort your mission, or you have to bring back your drone, or maybe you have to
Right.
change the altitude or all that. So here it is turbulence intensity. So if it is a light, there might be a sudden rise or drop of 1 meter. But if it is moderate, it could be 3 to 6 meters. Okay, it brings may be hardly noticeable to the face. This is normal actually. But in moderate, it may possibly be. So that time they will, sometimes if they are serving the food and drinks, so a lot of time they will say, okay, we are as of now aborting our
Suspending, yeah.
yeah, suspending our activities. Rise and drop up to 30 meters. So this is very severe. Occupant may be thrown if not strapped in. So that's why most of the time the pilot will give the first instruction that you could be at your seat. You are not allowed to go to the washroom, and you have to say fasten your seat belts, all that things. So that's about the weather and meteorology.
Nice.
Okay. So any questions so far on weather and meteorology? So I'll just show you. Uh, 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 where do you see India's weather, okay, overall weather? So you go to, I don't know, you might be knowing it, just from a perspective of knowledge perspective, I'm just showing you. If you go to Google and you type IMD, okay, so Indian Meteorological Department, here you can see the map. You just click on satellite, okay, you can see the current weather. So as of now, you can see the cloud is
Sky
somewhat
is clear.
there, or in the border area of north eastern side, and in the Arabian Sea and Indian Oceans. Not in Arabian Sea, but Indian Oceans, you can see the clouds. Okay, but whereas the complete peninsula is very, very crystal clear. So if you go out now, also you will see good sky. You can see stars and all the things.
Right.
You can see here Mumbai. So this is the you can just spend some time over there. You can see historical data. How the movements of the weather is clouds. See, this is
Yeah.
maybe how much morning 8 till 14 2 p.m. 14, yeah. From morning 8 to 2 p.m. data is there. Daytime data is there.
Right.
You can see the water vapor motion. So this is how you have this data, or weather department will have this data, positioning of the clouds and all. Based on this, they will have hundred of years of data since whatever the data they have, and based on that data, they will try to predict a particular day or thing how it will be on various factors. Not a single factor. There are multiple factors will be taken into consideration, and based on that, the simulation model is being created. And this is through the INSAT 3D satellite.
Okay.
So different Indian government has satellites which actually gives them the data monitoring on regular basis. Okay,
Yep.
we'll take a 5 minutes break. We'll resume by
Sure.
that. Yeah.
Yep.
that scenario, what I will do? I will just initiate the RTL. So it is beyond my control. The drone will autonomously will come and land, right?
Yep.
So what is emergency? Emergency is a situation that poses an immediate risk to the health, life, property, or environment. An unforeseen combination of circumstances or resulting state that can call for immediate action. Okay, this is unforeseen combination of circumstances or resulting state that can call for immediate action. So emergency is like situation that poses an immediate risk to the health or life or property or environment. So we need to know how to handle any kind of emergency. It could be emergency due to, like for example, suddenly the wind is there. Suddenly you
Mm-hmm.
have emergency. Suddenly you saw that your battery voltage is dropping very fast. So that could be the emergency. Suddenly I could see that I as a pilot, as a human, I am not feeling well. Or suddenly I am having a serious headache, or something which may be impacting my performance. That is emergency. So in that
Yes, sir.
scenario, how do I take care of my emergencies? Okay, so there could be different types of emergency, as we said: fire, medical, environmental, human, or could be technical also. Okay, sometimes all of a sudden your motor, like when we are driving a car, sometimes the car, we feel that it is not functioning as it's supposed to function. Usko gadbad ho raha hai. So what we do normally, that's we just take the car on the left side, stop it, open the, and check out what is happening.
Right.
That, sometimes tire tire has a different pressure. So मेरा गाड़ी drift होता है left right ऐसा थोड़ा. So then I see that some problem is there. I'll always park it on side and then check it out कि भाई whether I have a proper air pressure in my tires or some problem is there. कभी कभी flat हो जाता है कोई tire. Nowadays we do not know because we are using tubeless tire. So sometimes we don't get feel कि
Right.
flat हो गया. तो मैं थोड़ा सा drift होता है पता चलता है, but we can drive. So we know, okay, now there is a
Right.
flat. Normally I will see whether I can change. How do I mitigate risk? By having a stepney in the car. Okay, so I will
Right.
immediately change and put it, and so that at least I can take my car to the nearest garage,
Service center.
saying, yeah, puncture wala ke paas, kind of thing. So that's how you mitigate the risk. Okay, there could be a fire, there could be, like, sometimes battery over the period of battery cycles, sometimes it can catch fire. Okay, or there could be
Yep.
any
Yep.
medical situation could happen, or could be environmental situation also. I give example of human also. Like all of a sudden you're not feeling well, right? Or you might be having some problem. All of a sudden your stomach is upset, or you're feeling a pain in your stomach. In that scenario, you are not comfortable flying. So
Right.
that kind of emergency, you should always have some plan to it. Okay?
Right.
Emergency plan specifies the procedure for handling sudden or unexpected situations. So any type of this kind of emergencies, you should have a plan. Like that's why we said we always have two pilots. Both people getting sick is a rare chance. In the
Right.
in the aviation world, both pilots are not served the same food. Reason is that कि अगर एक
Right.
food की वजह से किसी का stomach upset हो गया और he is not feeling well, the other person should not also have the same effect. That's
Exactly.
why either इसको coffee दिया तो उसको tea दिया जाता है, उसको sandwich दिया है तो उसको something.
Right.
They will always give a different food to different pilots. So that's how it is. Okay, so what are the emergencies? One is loss of communication or control link. So what is the possible effect because of loss of communication or control link? RPAS crash into one or more buildings. Okay, or obstacle resulting in widespread secondary injury to humans from US debris or building damage. These are the possible effects because of the loss of communication or controlling. So how do you overcome this, or what is the plan you can have to overcome this? So if you have a communication loss with respect to the drone and the RC, what should happen? Immediately there should be a trigger. Okay, the communication failure will trigger the smart return to home feature, where aircraft return at a safe altitude or a safe location. Or there could be these are the settings. Okay, these are the settings within the drones FS form करके. Okay, so when these are set, it will automatically detect that it is not able to communicate. See, when your drone and RC is communicating, there is a check always happen between the drone and the RC. Especially drone will always check whether it is able to send signal to RC and RC is acknowledging that recipient of that signal. Okay, if that recipient of that signal is not received from the RC, automatically will drone know that it is no longer under the control of RC. That point in
Oh,
time, it will always trigger automatically the return to home feature, just to safeguard, because
right.
you are not in control of your drone. The pilot is not in control of the drone, so automatically it has to take that mitigation plan or contingency plan. Okay, that's why it will automatically trigger the smart return to home feature. Okay,
But will that also happen if, let's say, let's say I'm standing at point zero, and I am flying the drone in some one particular direction and it has crossed your radio or communication channel. Will it still come back?
see, for example, I'll give an example. Let's say you have a drone and you have a remote control. Okay, now the
Mhm.
communication between that remote control and the drone range is, let's say, 2 kilometers.
Okay.
So within that 2 kilometer diameter, I'm able to communicate.
Right.
I'm able to communicate. Okay, imagine now you give a thrust. Okay, you give a pitch forward, and it crosses
Right.
2 kilometers. So as it
Right.
nears the 2 kilometer, as it is given thrust, it will keep on going because it is given that Newton's
Command.
second law, right? As you are given already the
Right.
push, you are given the command, it will keep on going.
Right.
It will keep on going because it has received that signal. Now what happens? It
Right.
crosses your 2 kilometer. Immediately after 2 kilometer, whether the signal will die? No. There will be some communication,
Mhm.
disconnection, connection kind of signal will happen still. So the
Right.
drone will try to send its position, its information to the remote. Remote will acknowledge and send back to the drone. So that check is happening. Okay,
Okay.
that is called as a communication handshake. Okay, that is called
Okay.
communication handshake. So that is happening till the time drone is able to know that there is a communication happening between itself and the RC. It will be there. Moment it
Got it.
will, let's say, 2.3 kilometers, where it is not
Right.
receiving a handshake, then drone will know
Mhm.
the algorithm, the software which is there, which is functioning, or the flight controller which is functioning on all the inputs and parameters, which keep on
Right.
monitoring. It will automatically know that it is not receiving the handshake. That means it will know that there is a loss of link or loss of
Right.
communication. So what will do? Drone will take on its own. It will know that what is in this
Hmm.
scenario, what needs to be done. It needs to be initiate RTH or RTL
Right.
automatically, because GPS might be there. It is only the loss of communication between the
Hmm.
RC and the drone. GPS would be
Right.
there, IMUV might be working. So based on that, whatever you have configured into the drone, based on that, it may be land at that point of location also. It may land immediately there.
Asha.
Safely it will do, or it will come back to RTH, home location, or launch location,
Got it.
based on whatever the scenario is. You got it?
Right. Right.
How the emergency are being taken care. Imagine
Yeah.
you have not configured this RTH or anything. What would happen? The drone will
It
chala
will keep on
jayega.
flying.
Keep on. That is called flyaway,
Right.
stray away situation. Okay. To avoid that, also we have a procedure to do that. Okay. Let's see
Okay.
that. So this is the next immediate. What is aircraft flyaway? So what we do? Geofencing. So it will not
Got it.
cross. It will not cross your 2 kilometer. This thing only. You set a geofencing. Even you give a thrust,
Right.
it will go up to 2 kilometer, but it will immediately, it knows it's trying to cross the 2 kilometers
Right.
geofencing. It will
Right.
initiate. It will initiate your RTF.
Oh.
Fly away emergency, which occurs due to GPS or hardware software failure, is known as strain. So
Got it.
it could cause mid-air collision or crash into building or obstacle, crash debris, injuring people on
Right.
the
Right.
ground. These are the effects. Okay, but how do you have condition for contingency plan for aircraft not to fly away? So what is there?
Right.
You enable geofencing. It is
Geo.
always enabled and does not allow pilot to fly outside the defined corridor. Okay, so you
Got
have
it.
your geofencing is your horizontal artificial fencing. Okay, so
Right.
you will neither left right or up left right or up front back. You will not able to move your drone. That, whatever the geofencing you have set, and anyway your drone also has been hardwarely locked to say that your drone can fly only up to 400 feet, not
Right.
beyond. Okay. Now in DJI you do not have that limitation. Somewhere you can override those limitations also. Okay. But whereas in these type certified DGCA drones, you cannot override. You need access from the OEM. So there is a separate login
Got it.
which is required from the OEM. OEM will only give it to the people who are authorized or who are supposed to know those. Okay, like us,
Right.
we do the maintenance of the drone, so we need a lot of time those logins also for some other activities also. So that's why we have those logins. So we can change that settings. Okay. Like if it's 400 and I
Got
want
it.
to increase to 600, I can increase to 600, and then it can go
Right.
beyond 400. But then it will record in the logs that your drone is flown above 400 feet. Tomorrow
Right.
DPC ask for the logs, and if they find, they will take that log, and they have a different tool where you just deploy the tool, and it will tell me the non-compliance of from the logs. So whenever
Right.
I have done any breach or anything wrong or something like that, they will come to know. Okay.
Right. Makes sense.
Okay. Lot of time people do not monitor the battery of the drone. They keep on flying, or all of a sudden your battery goes down, loss of power or failure. In that scenario, what will happen? Uncontrolled descent or landing could cause serious injury to many
Right.
persons on ground or possibly the fatalities. Chance of mid-air fire leading to damage of the ground assets or crash landing. Okay, so what is the normally, see, all of a sudden you are losing the battery power. You can't have any emergency situation for it. In that scenario, you might have to put have something like a parachute or something like that.
Right.
But suppose sometimes your battery is there, you are charged it at 100%. You are flying, you see that it is 80%, 70%, 60%. Sometimes the battery depreciate very fast. All of a sudden it goes
Right.
from 70% to 650%. Okay. Now you are supposed to fly a drone within 50%. Okay? 50% of your battery capacity. Okay, that is what is the standard procedures people follow. Okay.
Mm-hmm.
You can't go up to 10% or like that, or very very low battery, which will be difficult in case you have any kind of emergency. So normally when we are flying a drone in a training, we'll always, on a safety side, we'll always put it up to 50%. Okay.
Right.
50% we'll keep it so that we can safely land or do whatever the activities we need to do. So there is an option set into the drone which is called battery failsafe caution. The moment it crosses that caution limit, what is been set, it will start triggering. Initially, it will give you the warnings and all these things. But the moment you cross 50% or 40%, whatever you have set, okay, some people set it even at 60% also. Threshold. If you moment
Right.
cross that threshold, automatically it will initiate RTH or RTL based on what is you have defined into the configuration of your drone. Okay, so it will automatically land autonomously at a predefined location. So what is that setting? It is called FSPAT, battery failsafe. Feature is available for this.
Mm-hmm.
So if battery voltage is less than 12.2, sorry, 21.2 voltage, automatically it will switch to RTL mode. Automatically it will take over. Sometimes you can override that also, and you can keep on flying. A lot of
Oh,
people
okay.
people are doing people do like that. When the RTL is initiated, you can override that RTL also, and people keep on flying it because it's hard coded into the configuration. Okay, so a lot of people will smartly saying it's already I will do it and then I will manually. You should not do
Right.
that, okay, because you are putting drone at a risk. If you want to do it, like if it is set at 50% and you want to change it to 40%, you should do that configuration and do it. So that means you know what is your doing. Imagine you override the RTL and you keep on flying. and you further suddenly degrades your battery, or go down in battery, you will land up into the emergency situations. These are the effects what it is talking about. Uncontrolled descent or landing could cause serious injury to many persons or ground or
Right.
possible fatalities. Chance of mid-air fire leading to damage of ground assets or crash landing, because as the battery is getting discharged, no, it is getting hotter, it's hot. So when the drone lands, after consuming of 50%, 60% of battery, if you hold the battery in hand, you will see, like even mobile also, like you will see a lot of time it becomes hot. You know,
Yeah, yeah.
as the more battery, like if you are playing a game, especially you are playing a game, your battery is getting discharged very fast. The normal operations of your mobile, you will not feel your uh, mobile hot. Okay, but if you're
Right.
doing something, you're watching video, or you're doing something, WhatsApp पे कोई video आया, ये आया, Insta पे you are seeing a lot of things. You will see, you can feel your mobile getting hotter, right? Backside hot हो जाता है. तो आपको लगता है
Right.
कि हाँ, okay, I was using application. So that's the discharge. You're pushing battery at the limit. Consumption of your power is high. अगर आप मोबाइल नॉर्मल रखो, जस्ट फॉर स्पीकिंग, टॉकिंग, सिंपल texting, all the thing, your mobile will function very very smooth. But all of a sudden you put pressure
Right.
on it, will become hotter. Okay, so that's how same thing applicable to the drone batteries also, because end of the day they are all lithium ion. Lithium, right? Okay, so this is the third type of your emergency. Then ARPA's loss of control again. Okay. Undesired flight trajectory could cause mid-air collision with other ARPAs or manned aircraft. Okay. Landing could cause a serious injury to many persons or ground or possibly death. Sometimes even drone itself loses the control. The drone is on its own. It may not having a receiving a signal from GPS, because
Right.
from the GPS signal we are controlling the drone, and drone is not receiving GPS signal, or IOM is having challenges. All that things, ARPAS is beyond your control. You try to control from your stick, you are not able to do. So there is a mode which, in such scenario the drone should automatically recover from this situation, which is called a position hold session, or stabilization session should happen. Okay, based on the position hold, based on the GPS and INS, reduced to uncontrolled action base. So in that, let's say you have a GPS loss. All of a sudden there is a cloud cover, and you are not getting enough signals from your GPS satellites. It will suddenly start behaving like a loss of control kind of thing, because it is not receiving enough GPS signal to be stabilized in a stabilization mode. So what it will do, it has its own built-in feature based on IMU. GPS is not working, so IMU is the best information or sensors to
Right.
give the inputs to the flight controller. So based on that, it will try to stabilize on its own. Okay? It will try to stabilize its own, or in case it is not flying as the desired way, then you should manually try to control the UAV. You should put it in a manual mode, not in a autonomous or GPS mode. You put it completely in a manual mode, and just using the four sticks, I mean four motions, you should try to land or recover the UAV to land it safely. But something sometimes emergency happens in such a way that whatever options you think, you are sometimes they are beyond human control also.
Right.
So emergency like unsuccessful landing or flight termination, vehicle breaks up or totaling, or post crash fire that injuries ground crew, threatens wildlife environment, RPS collides with the building, bridges or obstacles, causing debris that injure or cause fatalities. In that scenario, best part is to always initiate a smart return to home. Is always active, thereby preventing aircraft from landing outside the defined area. Okay. You normally the landing. See, landing is very crucial part. Okay, so you can do practice of landing and all things, but it is always safe, advisable that whenever, see, when you are taking off the drone, what you are trying to do, your drone is at a very stable ground. You are giving a push. You as it you push, it is in the air. You can just give little bit throttle. So it is good at a height and it is flying in the air. But when it is landing, as it is coming nearer to the ground, because of the weight, and see, it has to counter both. It has to come down as well as it has to be flying in the air also. I mean, it has to perform both combinations at the same time. It's a very crucial part of the flying when you are doing the landing of a drone. Okay, so as it is coming down because of the weight, okay, as you have reduced the throttle, it is coming down, but as it is closing close to the surface, somewhere around 3 meters or 5 meters, you will see suddenly, you will feel that your drone is not in your control, and there will be little bit panic in your mind, whether I will do it properly or not, whether I will do it properly or not. So you have to keep calm yourself. You have to slowly. If you feel that you're not comfortable or confident of landing it or touching it down on the ground, you should not do landing. You should take it up. You try it little bit up, stabilize it, and then again attempt that landing. Similarly, like you must have seen in the aviation world also, a lot of time when they were the aeroplane
Yoga.
supposed to land, and you see that you are not aligned to the runway. What you do in that scenario? You will always climb. You take a circle
Right.
and again come back. You align. I mean, you take that time. You breathe. You stabilize your mind. By the time you take a circle, and then you align yourself calmly, and then you take the line. That is what is the procedure followed in the aviation. Same thing you follow in your drone operations also. Okay. Drone operation, though you do not have person or thing, but again your drone is also expensive device, so you should always careful while doing landing and all. Okay. Now, emergency like coastal remote takeovers or control of army. These are something like some third person can take control, because again you are commanding your drone at 2.4 gigahertz. So a lot of times this can happen. So how do you make sure that this kind of scenario doesn't occur in you? You always have anti-tampering measures have been implemented. Hardware is detectable by only specific proprietary software and is accessible only by the machines installed with the driver. So it is not that any remote, like I will be having two remotes on the field. That doesn't mean that any remote I bring similar type of remote and it will try to, like if you see in a toy drones, they are not binded. If you have a two drones, sorry, one drone, and you have a same type of two remotes, those two remotes will try to communicate to those toy drones at the same time. Okay. But whereas in our DGCA type certified drones, our remote control is not like that. Or even in DJI, they are binded. There is some binding mechanism is been set, and you cannot change. If you want to do a change of remote, then you have a different procedure. You have to unbind it and you have to bind it back to that particular drone. So that's how this. Or you cannot change the software in the drones. All that mechanisms are been put. The software interface used for the firmware access is protected, because you can hack the drone. You must have heard a lot of times drones have been taken control and all that things. So if you do not put those anti-tampering measures or access control systems to your software and hardware, your drone could be taken over by some other devices also, like how we know in our computer things. If you do not put antivirus in your software in your PC, anybody can take a controller, can put some Trojan or some virus
Right.
in your laptop or your desktop and can take control of your system. Similarly, is applicable for drone. Okay, so as of now, there are not much uh, features put up into it, but in near future, these things will. That's what I was giving yesterday example. Today, your drones are at the same stage where the computer was there in 1980s. Over the period of time, your drones will also evolve. They will also have almost same evolution would happen. What we have seen evolution in computers or even mobile phones,
Right.
right? Okay. What are the threats and error management? Threats and error management is an overreaching safety concept reading aviation operations and human performance. Okay, the 10 framework is conceptual method. As of now, this is very at a conceptual stage because we do not, people have not evolved as of now how the human performance would impact the drone operations and all that things and vice versa. Okay, so framework is a conceptual model that assists in understanding from an operational perspective the interrelationship between the safety and the human performance in dynamic and challenging operational context. There are three basic components in the 10 framework, that is threat, errors, and undesired states. Okay, what are threats? Threats are generally defined as the events or errors that occur beyond influence of a line personnel increase of operational complexity and which must be managed to maintain the margin of safety. So, like for example, increase in operational complexity. Like you must have seen, like a pilot is flying. For example, let's say I am Utsav is trying to do a mapping of a tower. Okay.
Hmm.
Now, when you are seeing a tower, he is flying. Okay, he is flying, and with his perspective, his job is his focus is more on the drone. Okay, so he is not seeing anything because sometimes over the period of time you are flying, you are only seeing the drone. You are not seeing anything.
Right.
Okay, it happens. Psychologically, it happens that way. That's why we always have a co-pilot. The co-pilot is not actually flying the drone, so he is not seeing. He is seeing the bigger picture. So he is saying where is the drone, where is the tower, where is the wire, whether you are going to hit the wire or you are going to touch the wire or something. So he will immediately inform the pilot. Once you are going very near to it, reduce your flight, you reduce your height, all that things inputs which pilot may not anticipate at that point in time. The second person who is not actually because he is not in pressure of flying the drone, he is just observer, so he's like a critics. So he will always tell, okay, you are doing something wrong. You know, his mind is working like a.
Right.
So that's how you should have people more. That's why we always prefer to have two people when we are flying the drones or we are doing activity. Nowadays, even in agriculture, spraying and all those things, people are sending two people. Like one pilot is a trained pilot, those second person maybe not be a pilot or maybe a pilot who has just completed his licensing and he want to learn, so he will like a buddy kind of thing who is actually trying to learn, and over the period of time down the line 3 months or 6 months he will also become a independent pilot, or he may become a
Right.
and then he will have somebody under him or along with him to be trained kind of thing. Okay. Errors are generally defined as actions or inactions by a line personnel that leads to deviation from organizational or operational intentions or expectations. So a lot of time, people, like example I said, we have set a rule that we
Like
will
when people
not.
make mistakes while flying, right?
Yeah,
Errors.
yeah. That's what I'm saying. That is what I'm example giving you. So we have, like initially when we were flying a drone near the power line tower, one of our Mavic drone went very close, and suddenly it crashed. After the analysis,
Hmm.
we found that it is because of electromagnetic waves. Okay, so we checked with the OEM what is the standard distance we should maintain when we are flying the drone near to the power line towers. So we found that it is somewhere around 5 meters. Okay. So to be on safer side, we defined like not to keep 5 meters, but we'll say we take 8 meters. So we defined that we'll not take the drone closer to the tower, very close. It will be keep it a safe distance of 8 meters.
Right.
What we follow. So if we do not follow these procedures, definitely these are errors or mistakes. Okay. So these are operational, intentionally, or sometimes you do not know actually. Sometimes mistakes or errors happens intentionally or sometimes unintentionally. Because you can't measure every time what is the 8 meters. You should. That is a very generic perception. You said, okay, I will try to fly. Nowadays, there was no software. Okay, there was no software. Like in agriculture, we have a software for mapping. You can plan your flight path. But earlier there was no
Right.
flight path defined for the towers. So now there are softwares has come, which actually where you can define, you based on your height of your tower, your base definition, like width and the length of the tower and the height of the tower. You can actually make a picture of a tower, and you can define your paths of how you want to fly your drone around the tower and capture the data. So that autonomous feature is has come up now. Earlier, when we were flying 1.5 year back, there was no software available. So we have to do it manually
Mm-hmm.
on our own. So that error is possible is there. Okay, though we know that we don't have to fly very close to the tower, but we try to do it manually on our own. But now the softwares have developed so that you can put a flight path into it, and you can plan your flight around the towers and take it safely, do the activities safely. Okay. The last option is undesired state, generally defined as the operational condition where an unintended situation result in reduction in margin of safety. I mean, these are something which is beyond your control. Okay, generally defined as operational condition where unintended situation result. All of a sudden, something happens. I have seen like I mean, there was a video online. Okay, will show you very classic video. I'll show you what is anxiety effect. This has come on WhatsApp recently only. You can see the screen.
Yeah.
You can see the video, right? Video. I mean, I have not played it. You can just.
Yeah. Yeah.
We can see it, sir. You haven't played it yet, but we can see it.
I'm playing it. Okay. See now. What is happening? It's a very normal condition. You are flying. You are landing in the drone. You landed. He landed. Now see what happened.
Right.
अरे रैम द रैम आर्म नहीं हुआ क्या? So after the landing, it has to disarm the drone. So it was the problem was continuously moving, and all of a sudden it just toppled, tip per tip.
Mm-hmm.
क्या हुआ? अरे this happens if there is a change in the rotational speed of side. I mean, one side propellers are moving a little bit faster than compared to the other side propellers.
Right. But is this an error from the pilot side or?
No, no, not proper. It didn't get disarmed. Ideally, it should get disarmed
Right.
in 3 seconds. It didn't. It didn't get disarmed.
Got it.
There was some error in the software itself. Okay.
Yep.
These are undesired effects. So we need to understand why are these, or what are these errors, why these errors come. Something which is beyond your control. Here you are not doing. You are just landed, and it's supposed to be disarmed on its own in 3 seconds. It didn't disarm. So something undesired state. Okay, this was not what we were intending, or this was not supposed to be happening, but it happened. That's which is beyond your operational condition, and there is a reduction in margin of safety, or loss of device also, or something could happen. Okay. So what are the emergency identification? How do you handle, I mean, identify emergency? It could be pilot error. It could be because of heavy wind, loss of altitude, remote control failures, compass failures, sometimes motor or popular damage, okay, or medical emergency. Medical emergency, it's a pilot not uh, keeping well or falling sick, or he's
Right.
under influence of a drink or something like that. Those are could cause medical emergencies in our life. Okay. So with that, we complete the emergency handling topic. I think it's almost 9:58. So we are done with today's topic. So tomorrow again at 7 we'll there, and tomorrow will be the last day. And we have only now three topics: drone equipment and maintenance, and then
Okay.
payloads, and then we have
तबीयत खराब हो गई.
based on the payloads, whatever the image and video interpretation, what normally we do with respect to the data what we capture. Okay.
Right.
So you have any further questions, or we can conclude today's date. Okay. So I have already given you the dates for it. So you need to. Acha, before I say, how are you people going to travel to Igatpuri? I mean, to our location. I have given you the location details and all that things, right? Have you
Yes,
What
received?
is
sir.
what is the best possible transport?
Best is take a train from Dadar,
Okay.
Tapon Express in morning. I think somewhere I don't remember the exact time, but 5:30 or something it starts.
Mm-hmm.
It reaches around 8 and 9 के बीच में someplace.
Okay.
There are three trains at this almost same times in difference of like 15-20 minutes kind of thing.
Okay.
Long distance trains are there. So Tapon is supposed to be the best. I have personally used it couple of times.
Mm-hmm.
Okay. Or there is a bus also. I mean normal buses which fly. I mean which not fly. Drive from Dadar to Goti. Okay. Either you go to Igatpuri or you come to Goti.
Okay.
Places.
Okay, sir.
Okay. So if you reach that place, from there you have to. I mean, I would say first thing is you need to book from how are you traveling from Mumbai to Igatpuri or Goti. Okay, that is first thing you need to plan. Second is once you have defined that, I would say that you two people and then there are two more people are coming. So all people has to come at the same time. At least you have to reach on 12 by 11. Okay, so you might be people starting from different locations and all that thing. Okay, but if you plan, everyone plans. Let's say plan to come by a train. You take a book Tapon Express. You reach Igatpuri station. From there, you can have a cab. Okay, which normally charges around 1500 to 1800 rupees. Okay, so if four people are coming, you can get that divided among the four people. So it will be like how much? 300 rupees per person. So same cab wala you can tell while going back also on the third day. He will also come back. He will pick up you and drop you to Igatpuri.
Right.
So evening I think 7:28 का कोई train है. So which will take 2 hours to reach Mumbai. So that's the best option to travel actually.
तो 11th को शाम को we'll have to leave ना.
Not 11. Morning you can leave now. 2 or 3 hours max, 3 hours, 4 hours higher side you can see is your travel time.
अच्छा सिर्फ 4 hours का ही है क्या.
Ah,
ओके ओके.
so let me tell you. Check what is Tapovan. Normally, I will always tell student to take Tapovan Express. That is the best train, and very. I mean, it's not that expensive and simple. There is another train also after Tapovan, which is little bit expensive, but getting tickets in those is little bit challenge. So you can book the ticket early. Now only if you book it, it will be easier for you to getting it. inside the train. I mean, comfortably, AC train. So that is what. If you want to, I mean, or else you, if you have any plan to come on your own vehicle and all the things, that's altogether all your choice.
Okay,
Roads are
sir.
good there.
Hmm? Sorry.
Are roads good? As in, like, if we plan by car?
Yeah, road are good.
Okay.
Roads are good. Road is not a challenge. Somewhere in between, some work is happening, because that work is that Samruddhi highway is getting built over there, or in some places, some in between there are some works are happening. Okay, subjective uh, of the work carried out by our government. But okay, I mean, I have been going a lot of times over there. I go to a lot of,
Right.
I go regular to Nasik. I go regularly to Shahpur, and other places also in that area. So I keep on. I mean, I have a couple of other places to visit those locations. So I have seen.
Okay. Okay.
So there is a train called LTT GKP Express. Okay, that starts somewhere around 6:35. Okay, and Tapovan I think comes little bit later. Tapovan starts at what time from Dadar? 5:48. Okay. There are two. These are the two trains. Normally, most of the time, people have been traveling to our place either through Tapovan or LTT GKP. So these are the
Got it.
two. So LTT will reach around 9. Tapovan will reach at 8, somewhere around 8, 8:10 or something. 8:20 max. 8:10 it reaches. Okay. So you can do that, and you need to do the booking for the resort also. So I will share you the. I think I shared you or not.
No, no.
No, I have not shared you the link, no, to do the booking, because I have already spoken to resort and given them the dates that students are going to come and all it. So you need to do the payment to them so that they can book the rooms for you. Okay, so I have given you the location. I have given you the maps in case you have, and of course I will be also available on mobile in case you get anytime any challenge or any issue. Okay. I'm always available on my mobile, so feel free anytime in case when you are traveling or if you are planning to travel, how and what. If you need any help, you can directly call
Sure.
me. About it.
Sure, sure.
Okay. So thank you very much for the today's day, and
Thank you, Mangesh ji.
good night.
Thank you, sir.
Yeah, good night.
Good night.
Both.
Good
Bye
night.
bye.